Let's start the topic for today. We will be discussing three problems from the chapter Kinematics of class 11. These are all from the IIT JEE mains exam. So the first question is from 2019 mains. Let's go to the question directly. You can see one second. A particle is moving with a velocity v equal to k into yi plus xj, where k is a constant. The question is to determine the general equation for its path. Okay, that means there is some particle. Okay, there is a particle which is moving with some velocity k into yi plus xj. We are asked to determine the general equation for its path. Okay, so first let's see what its velocity is. If you look at this velocity term, you can see the velocity has I component and j component. That means it has got both x component and y component. Okay, a particle is moving like this. Suppose it's moving like this. That means it's not simply moving in x direction, or it's not simply moving in y direction. It has both. It has velocity. It has got velocity in both x and y directions, right? Because you can see the velocity vector is given by k into yi plus xj. I and j indicates that it has got an x component which is equal to what, ky, and y component which must be equal to kx, right? So the particle must be moving something like this. Okay, we don't know. We are asked to determine the equation for its path. Right now they have given the velocity for the particle. We are asked to determine the equation for its path. Okay, we only know the velocity equation. So first write the velocity equation. Velocity is equal to k into yi plus xj, right? And let's diagnose this even further. You can see this is the x component and this is the y component of velocity. What is the x component of velocity? X component of velocity is ky, right? So vx is equal to ky. And what is the y component of velocity? Y component of velocity is, you can see, it is 1 with j. So the k will come here. So it becomes kx, right? So the y component of velocity is kx. So we have two velocities, vx and vy, and vx is equal to ky and vy is equal to kx, right? So now we got the velocities, the two different velocities, the x velocity as well as the y velocity, right? So let me write. You just got vx. Okay, this is vx. What is vx? Vx is equal to ky. And we got vy also. Okay, this is vy. What is vy? Vy is equal to kx. Now we have the velocity. We need to, if we have velocity, we can see what is vx. Vx must be dx by the rate of change of displacement in x direction, right? So vx must be equal to dx by dt, right? So you can see here, this is dx by dt, which is nothing but vx, right? So I can write vx as dx by dt, and which is already equal to ky. So I can write dx by dt is equal to ky. One second. Dx by dt is equal to ky. So from here, what you can write? Dx must be equal to ky into dt, right? So dx is equal to ky. The dt comes here. Okay, so dx is equal to ky into dt. Similarly, what is vy? What is the velocity of particle? Velocity of a particle in y direction. The velocity of particle in y direction will be equal to rate of change of displacement in y direction. That means dy by dt. Okay, So Vy must be equal to dy by dt. And we know that Vy is already found out to be kx. Right. Here we have Vy is equal to kx. That means dy by dt is equal to kx. So dy is equal to kx into dt. Right. So right now we have dx as well as dy. So dx is equal to ky dt, dy is equal to kx dt. Then what will be dy by? So these are the two equations we have, right? From here we need to find some equation connecting x and y, some equation connecting its motion along x and y, right? Motion along the xy plane. Okay, so let me divide these two. This is dy, this is dx. Let me divide these two equations. On the LHS, it could be dy by dx. Okay, I'm dividing. If this is equation number 2 and if this is equation number 1, let me divide 2 by 1. Then it becomes dy by dx is equal to kx dt by ky dt. Dt gets cancelled, so it becomes kx by ky. Again, k is also there in both numerator and denominator, so k also get deleted. So dy by dx is equal to x by y. If I rearrange it, it will be y into dy is equal to x into dx, right? Y into dy is equal to x into dx. So if I integrate this equation, y into dy is equal to x into dx. If I integrate on either sides, what is integral x dx? It must be x square by 2. What is integral y dy? It must be y square by 2 plus integration constant c. So we have x square by 2 is equal to y square by 2 plus c. So multiplying, we get x square is equal to y square plus 2c. 2c is it again another constant, put it as k. So x square is equal to y square plus k. So that must be the answer. So let's go to the option. X square is equal to, what is our equation? What we got is x square is equal to y square plus a constant. Let's compare what we have here. Uh, this is not the answer because there is only y here. Again, here y square is equal to x plus constant. This is also not the answer because both x and y should have square. So here it's xy, that is also not the answer. So option D, you see, y square is equal to x square plus constant. Both are like power of 2. X and y are power of 2, and there is a difference of constant between them. So this must be the answer. Okay, now let's move to second question. In this, you can see the question is, in three-dimensional system, the position coordinates of a particle in motion are given below. There is a particle here, okay, and it's in 3D. Okay, 3D means we have three axes as all the three axes as reference. This is placed in a three-dimensional space and it is moving. Okay, the particle is in motion, and at any time the coordinates are given by, if we have to, the position can be given only by x, y and z. We need to know all three, right? So the position will be given by x, y, c. And x is given as a cos omega t, y is given as a sin omega t, z is given as a omega t. Okay. And the question is to determine the velocity of particle. What will be the position coordinates are given, the velocity. This question is very simple. This is also from 2019 mains. The question is very simple. The coordinates are, the positions are given. We are just asked to determine the velocity of the particle. Okay, and we know what is velocity. Velocity is rate of change of position. Okay, so is equal. So we, if I take x, Vx must be equal to dx by dt, right? Dx by dt. So here, this is for x. Similarly, remember it has got. Try to understand this. This particle must be having velocity vectors in different directions. Yet finally, the resultant velocity will be in some other direction. It may have three different velocity vectors: vx, vy, and vz. And the final, the net velocity will be the resultant of these three. Okay. First, let us try to find out the individual velocity components. What will be the velocity along x? What will be the velocity along y? What will be the velocity along z? Let's try to find out these three. If we get these three, the resultant of these three will be the magnitude of resultant of these three will be the final answer, will be the net velocity. Okay. These three, the red color, these three might be the individual components x, y, z. This could be the net velocity, the resultant velocity. So first what we can do is, let's try to find out the individual velocity components. First, let's say vx. What is vx? Vx is equal to dx by dt. Okay, vx is equal to dx by dt. So here, what is x? X is a cos omega t. X is a cos omega t. So vx is equal to dx by dt, that is d by dt of a cos omega. What is x? X, I told we have a cos omega t, a cos omega t. So d by dt of a cos omega t, that is equal to, a is a constant. Okay, a must be a constant. Omega can also be assumed as a constant. Only t is the varying atom. Okay, so a is kept here. So a into derivative of cos omega t with respect to t. What is derivative of cos omega t? It is sin omega t into omega. Omega must be taken out. And it is minus. Since it is a derivative of cos, it must be minus sin. So minus a omega sin omega t is vx. Okay, similarly, let's calculate vy. What must be vy? Vy must be dy by dt. So what is y? Y is a sin omega t. So d by dt of a sin omega t. A is constant, so a is taken out. D by dt of sin omega t is omega cos omega t. So a cos omega t must be vy. Similarly, vz. Vz is dz by dt. D by dt of z. What is z? Z is a omega t. So d by dt of a omega t is equal to d by dt of a omega t. A and omega are constant, so it is simply a omega. So right now we have vx, vy, and vz. Right now we can find out the magnitude here. Here in the answer you see nothing is mentioned about the direction. It's only magnitude. There is no x component, y component, or ij. Nothing is there. So it's only magnitude. So if we have, so the velocity vector, we can write it. Velocity can be written as made up of say vxi. V must be equal to vxi plus vyj plus vzk, right? Vzk. This is a vector form. Then what must be the magnitude? Magnitude of v must be square root of, say, if a, b, z are the constants here, magnitudes here, then root of a square plus b square plus c square, right? So here the velocity magnitude must be, the magnitude of velocity must be square root of vx square plus square root of vx square plus vy square plus vz square. Okay, sorry, vz square. So let's take the square roots. v is equal to vx square, square root of vx square plus vy square plus vz square. So magnitude of v is equal to square root of, what is vx? Vx is minus a omega sin omega t. So minus a omega sin omega t the whole square. What is vy? Vy is a omega cos omega t. So a omega cos omega t the whole square. What is vz? Vz is a omega. So a omega the whole square. So it becomes v is equal to root of, if you take the square of this time, what will you get? A square omega square into sine square omega t, right? A square omega square, negative becomes positive, a square omega square sine square omega t. Here a square omega square cos square omega t. Here it becomes a square omega square. What do you find common in all these three terms? It's a square omega square, right? But before that, what we can do is, you see this term, first two terms, there is a square omega square common, and if you take a square omega square as common, you can put the sine square omega t plus cos square omega t in a single bracket. Okay, so plus the third time a square omega square. What is sine square omega t plus cos square omega t? It must be 1. So it becomes square root of, this whole term became 1, like, alright. So the whole term becomes square root of a square omega square plus again this third one, a square omega square. So it becomes square root of 2a square omega square. So it becomes square root of 2 could be taken outside, root 2 into a omega must be the answer. You can check the options, root 2 into a omega. Okay, this was also from 2019 mains. Now let's go to the third question. The position of a particle as a function of time t is given by x of t is equal to at plus bt square minus ct cube. As a function of time, remember, x of t with respect to time, it's varying like this, and it is given a, b, c are constants. When the particle attains zero acceleration, what will be its velocity? When the particle attains zero acceleration, when a becomes zero, what will be the velocity of the particle? Okay, but what is given to us? The x of t is given. That means the position is given. Then we have to determine, we have to correlate between acceleration and velocity. Okay, so what we know, if we have position, we can calculate velocity, right? V of t is equal to, what is v of t? V of t is, here the motion is only in x direction, there is no other y, there is no y or z, there is only x. So v of t is equal to d by dt of x of t, right? So v of t is equal to d by dt of x of t, that is d by dt of, what is x of t? X of t is at plus bt square minus ct cube, right? So d by dt of at plus bt square minus ct cube. Okay, so v of t is equal to d by dt of at plus bt square minus ct cube. Let's take the derivative. Derivative of at becomes a, derivative of bt square becomes 2bt, derivative of ct cube becomes 3ct square, right? So v of t is equal to a plus 2bt minus 3ct square. This is the velocity of the particle. Always remember, if we have position, then we can easily calculate velocity. If we have velocity, we can easily calculate acceleration. Okay, so right now we got the expression for velocity of the particle at any time t. But the question is, what is the velocity when the acceleration is 0? So the condition given is the acceleration has become 0. Now what is the velocity? Normally when acceleration becomes 0, velocity must be maximum or minimum. Okay, But don't think about that. For the time being, acceleration is given as 0. Okay. So let's determine the expression for acceleration. We have the expression for velocity right now, right? Let's determine at some point this velocity becomes 0. Okay. That is the final condition. Sorry. At some, this is the velocity with which the particle is moving. At some point, its acceleration has become 0. So we need to determine the expression for acceleration. What is acceleration? Acceleration is d by dt of vt. So d by dt of velocity will give you acceleration. That is d by dt of, what is velocity? A plus 2bt minus 3ct square. D by dt of a plus 2bt minus 3ct square. D by dt of a must be 0 because a is a constant. D by dt of 2bt must be 2b. D by dt of 3ct square, here minus will come, 3ct square will become 6ct. So 2b minus 6ct is the acceleration at any time t. At any time t, the acceleration of particle will be like this, right? Now it is given at some point the acceleration, this acceleration becomes 0. At that point, what is the velocity? Let's see at what point at what point the acceleration becomes 0. Let's see. Acceleration's expression is this, right? This becomes 0. That means 2b becomes equal to, that means 2b is equal to, this will become equal to 0, right? So that means 2b is equal to 6ct. Okay, 6ct. That means t will be equal to what? 2b by 6c. 2b by 6c, right? That means t is equal to b by 3c. T is equal to b by 3c, right? T is equal, at this time, at t is equal to b by 3c, the acceleration becomes 0. So right now we know when it becomes 0 acceleration. At t is equal to b by 3c, the acceleration becomes 0. Our question was, what was our question? What is the velocity then? If the acceleration is 0, then what is its velocity? So we know the acceleration becomes 0 at what condition? When time becomes b by 3c, right? So what is the velocity then? To know the velocity, we can apply it to the equation for velocity. Velocity's equation is a plus 2bt minus 3ct square. So let's substitute the time b by 3c into that equation. A plus 2bt, 2b into b by 3c minus 3ct square, 3c into b by 3c the whole square. So it becomes a plus 2b square by 3c minus 3b square by, here c square comes, but this c will cancel one c here. So it becomes b square by 3c. So a plus 2b square by 3c minus b square by 3c. These two denominators are same. So 2b square minus b square becomes b square. So a plus b square by 3c. So this is the equation. This is the expression for Vt. Right now you see A, B and C. Only A, B and C are there. All are constant. So you got a constant value right now. This is the velocity when t is equal to what? T is equal to b by 3c. Why b by 3c? Because it is at this time, this point of time, the acceleration becomes 0. So that's it. So let's see the option here. A plus b square by 3c. So yeah, here it is. You have a plus b square by 3c. This is option 3. This is also from 2019. So that's for this session. We will cover all the questions from all the previous years solved questions. We will go chapter by chapter. First, in the next session also we will continue with kinematics. In kinematics, we will have some 50 more questions. So we will solve all of them. This is enough for now. Thank you.